Hello again and welcome to our last video for fractions in DMA 20. In this video we're going to talk about section 6, which is adding and subtracting mixed numbers. In this video we're covering two things. First, adding mixed numbers, and then subtracting mixed numbers. And then we're going to look at a second method to perform these operations that involves improper fractions, and talk about why this method isn't really endorsed by the faculty at CCCC, because it can be quite difficult at times. And then lastly, we're going to look at an application problem. In the next video, we're going to start our discussion on decimals, and section 2.7 will cover an introduction to decimals. There's not going to be a lot of notes to take in this section. We're going to jump right in to some example problems, and we'll start with adding mixed numbers. So in this example, we have 4 1/6 plus 2 3/4. And the way we like to teach this is to set these addition problems up vertically. Something like this. We'd write it as 4 1/6 plus 2 3/4. Like this, just like we learned how to add and subtract large numbers when we were younger. Now, what we need to do here is find a common denominator, because we are adding fractions. Adding and subtracting, we'll always have to find a common denominator first. So the common denominator between 6 and 4, the least common denominator will be 12. That means I have to multiply the 1/6 by 2 to get 12, and the 4th by 3 to get 12. Okay, and I'm going to go ahead and rewrite the whole problem. So now I have 4 2/12 plus 2 9/12. Okay, now that I have common denominators, I'm ready to add. So I'm going to look at the numerators here and here. I have 2 and 9, and add those together to get 11/12. We'll do the fraction first. And then I'll look at my whole numbers. I've got 4 and 2, and I'll add the whole numbers together to get 6. So my final answer is 6 11/12. Now we'll always want to check this fraction part right here to see if it can be reduced. In this case we can't, so we have our completed solution. Here's another example with adding fractions. We're going to follow the same method that we used last time, but we'll see at the end there's an extra step that sometimes comes when we're adding mixed numbers. So we'll start by setting this up vertically. 45 2/3 plus 96 4/5. Alright, now to find the common denominator. The common denominator between 3 and 5 is 15. So I have to multiply 3 by 5 and 2 by 5, and multiply the 5 by 3 and the 4 by 3. Alright, and I'm going to rewrite this problem. 45, and now I have 10/15, and then 96 and 12/15. And I'm ready to add those together. We'll start with the fractions. 10 plus 12 is 22 over 15. And then when I add the wholes, 5 plus 6 is 11. We'll carry up the 1. 1 plus 4 plus 9 is 14. So I get 141 22/15. Now we have a little problem here. The 22/15 is what kind of a fraction? It's improper. And the whole point of using mixed numbers is to avoid improper fractions like this. So what we need to do is convert this improper fraction into a mixed number, and take the wholes and add it to the wholes that we already have. So let's do that first. First, 15 will go into 22 one time. Okay, and how many 15ths do I have left over? I'm going to have 7/15 left over. Okay, so I need to take this 1 and add it to the wholes that I already have. So my wholes altogether are going to be 142 and 7/15 left over. 7/15 doesn't have to be reduced, so I'm done. So let's talk about what happened once again. This improper fraction, we had to convert to a mixed number and then add the wholes in that number to the wholes that we already had to get our final answer down here. Now we'll look at an example involving subtracting mixed numbers. We're going to use the same method that we used with addition. So we'll rewrite this as 16 and 7/10 minus 9 and 8/15. The common denominator between 10 and 15 is going to be 30, so I'll multiply 10 by 3 and 7 by 3. And then I'll multiply the 15 by 2 and the 8 by 2 as well, so I can rewrite this problem. Now I get 16 and 21/30 minus 9 and 16/30. And I'm ready to subtract. I'll subtract the numerators. 21 minus 16 is 5/30. And then I'll subtract the whole numbers. 16 minus 9 is 7. Now in this example, I do have to reduce my final answer. 5 and 30 are both divisible by 5, so I need to go ahead and divide out that common factor of 5. So my final answer is going to be 7 and 1/6. Here's a second subtraction example. This is going to start out using the same steps, but we'll notice pretty quickly that we're going to have to do an additional step to complete this problem. We're going to have to borrow, and this is probably the most difficult thing that we'll do with mixed numbers. So I'll try and go slow. Make sure you're paying attention. We'll rewrite the problem. 34 and 1/8 minus 11 and 2/3, and start by finding our common denominator, which is going to be 24. So we multiply the 8 by 3 and the 1 by 3, and the 3 by 8 and the 2 by 8. And when I rewrite this problem, I get 34 and 3/24 minus 11 and 16/24. And now here is where our problem arises. I can't do 3 minus 16. 3 isn't big enough to take 16 away from it. So just like normal subtraction, I need to go over to the next place, and I need to borrow one from this 4. But when I borrow it, I'm not just going to add 10 and make this 13. I'm going to borrow it in the form of 24 over 24. So let's see what that looks like. I'm taking 1 away, so now this becomes 33. And that 1 that I'm taking, I'm not going to just add 10. Remember, 1 can be written as any number over any number. So what I'm really doing is taking that 1 in the form of 24 over 24, and I'm going to add those fractions together. Whatever the denominator is of this top fraction, that's the fraction that I take. It's 24, so I take 1 as 24 over 24. If it was 12, I would take it as 12 over 12. This just makes the denominators here equal, so I can add the numerators together. So I'm going to rewrite this problem again. After I borrowed, I have 33 and now 27/24 minus 11 and 16/24. And after borrowing, I have a large enough top fraction that I can actually do this subtraction. 27 minus 16 is 11 over 24. and then 33 minus 11 is 22. So this is my completed fraction, 22 over 11/24. 11/24 isn't reduced, so I'm finished. So if you're in a situation where you can't subtract these numbers right here, remember to borrow one of your wholes, okay, but borrow it in the form of a fraction using your common denominator that you found. There's a second method for adding and subtracting mixed numbers that's shown in your book, but it's not something that us faculty at CCCC really recommend. It is possible to add and subtract fractions by using improper fractions, but we suggest that you avoid it because it gets kind of messy. The numbers get really big really quick, and especially on a timed quiz or a timed test where you don't have all the time that you would like to complete each problem, it's not really efficient given the amount of time that we have. So rather than just tell you why to avoid it, I'm going to show you why to avoid it. I'm not going to complete this problem, but I'll show you how quickly the numbers are going to get big. So the first thing that we would do using this method is to convert these two fractions to mixed numbers. So I need to do 9 times 44 and then add the 2 and then write that over 9. So right away we're going to get a big number. 44 times 9, we get 36, 6 group the 3, 36 again plus 3 is 39. We get 396 plus the 2, that was our numerator, so we get 398, okay? And we're going to write 398 over our original denominator, 9, minus, now we have to convert the second fraction to a mixed number. So we'd have to do 76 times 21, then we're going to add that numerator of 20 in later. So when I do the multiplication, I get 1,596 plus 20. That's the numerator that I'm adding. I get 6161. So now I have 1,616 over 21. That's a huge numerator. But we're not even done. These numbers are going to get even bigger. Okay? Next I need to find a common denominator. The common denominator between these two fractions is going to be, let me see here, 21, 42, 63. I would have to multiply both of these numbers by 7 to get that common denominator, and 21 times 3 will give me that common denominator. So I'm not going to continue at this point, but you can see that I'm going to get gigantic numerators. So there's a lot of additional large number multiplication, addition, and subtraction, and eventually we're going to have to convert this back to a mixed number, so there's going to be some large number division too when we go and convert back. So this is why this is a method that we don't really like to teach in this class. If it's a method that you're comfortable with using, you're welcome to do that, but understand just how quickly these numbers can get extremely large and very hard to manipulate. Our last example for this video is an application. So here we have a triangle, and the perimeter of this triangle is 17 1/8 inches. What is the length of the third side? Well, remember how we find the perimeter of the triangle. We add up all three sides, and that should equal 17 1/8. So there are several ways to do it. I could subtract each side from 17 1/8 individually, but I think what might be a little more efficient is to add the two sides that we know together and then subtract that sum from the total, and that'll give us the part that's left over, our unknown side here. So that's what I'm going to do. I'm going to start by adding our known sides together. We have 6 3/4 and 7 3/4. I'll go ahead and add those up. Fortunately, I already have common denominators. I'm going to get 6 over 4, and then 6 plus 7 is 13. But again, I have an improper fraction. I need to go ahead and convert that to 4 will go into 6, 1, with 2 left over. Okay, so I need to add that 1 back into our wholes. I'm going to get 14 and 2/4, and reduce that's going to be 14 and 1/2. Okay, so that's the sum of the two known sides. Next, I'm going to subtract that from the total perimeter to get the unknown. So that'll be 17 and 1/8 minus 14 and 1/2. My common denominator is going to be 8. That means I only need to change the bottom by multiplying it by 4. Okay. And now I'll go ahead and rewrite this. But again, I have an issue here where I need to borrow. I can't do 1 minus 4, so I need to borrow 1 from here. I'm going to change this to 16, and then I'm going to add that 1 in as 8 over 8 this time. So my new fraction will be 9/8, and still subtracting the 4/8. Okay, when I subtract my fractions, 9 minus 4 will give me 5/8. And then I'll subtract my wholes. 16 minus 14 will give me 2. So the unknown side in this problem here is going to be 2 and 5/8. So that's all we had to cover in this last fraction section. To review, we covered adding and subtracting mixed numbers. We talked about why using improper fractions isn't the best way to do this, although it is possible. Then we looked at an application problem involving a triangle. In the next video, we're going to start our discussion on decimals. Section 2.7 is an introduction to decimals.